All right, so we're looking at the vertex and the axis of symmetry, maximum, minimum, focus, and directrix. All of those are related to the very same thing. So let's look at an example of that. Let's just start with something easy like y equals x squared plus 16x plus 8. Doesn't really matter there. Okay, so if we're going to look at that, what form is that equation in? Standard form. If it's in standard form, then we're going to use a little formula to get our axis of symmetry. So the first thing that we could find is the equation for the axis of symmetry. And if you remember in Algebra 1, if you y'all graph some of these things, these parabolas, but you know, the shape is something like this, right? That axis of symmetry is this imaginary line that says you could fold that across that line and it would match up on both sides. That's all that is, okay? So we're going to find that equation. That equation should always be x equals something. The formula that we can use if it's in standard form is going to be negative b divided by 2a if it's in standard form. That's always what it's going to be, okay? So for this one, you know, it'd be x equals negative 16 divided by 2 times 1, which would be x equals negative 8. And you'd simplify that if possible. You know, here they simplify it to be negative 8. If it's a fraction, that's okay. It just means that that's where the axis of symmetry is, okay, for our parabola or our quadratic function, whichever one you want to call it, okay? Once you find the axis of symmetry, that gives you part of the vertex for free. The vertex is always this ordered pair. The x value, if it's in standard form, is negative b divided by 2a. To find the y value, I use this notation. What does that notation tell me to do with negative b over 2a? Not times by f. This is function notation, so that means take that number and put it where into the equation? Plug it in for x. That's what that means. So we're going to take the negative 8 that we got here, and we're going to find y by plugging that in. And working that out. So that'd be 64 minus 8 times 16, let me 80 plus 48, be 128. Is that right? Well, with the calculator, help me out. This is negative 64 plus 8, negative 56. Is that right? Somewhere with the calculator. All right, good. So our vertex is this ordered pair, negative 8, negative 56. Okay. If I was going to graph this one, I'd have to have a pretty large coordinate plane, but I could change my scale, go by 8s maybe, and it works out pretty nice because I got an x value that's a multiple of 8, 56 is a multiple of 8. So I could change my scale and make it work out real nice. Now, once we found the vertex, then we need to decide, is that vertex a maximum or a minimum, okay? And the way we're going to tell is, look at our little handout, maximum and minimum is decided by what's a. If a is greater than 0, what kind of number are we talking about? We're talking about a minimum, and we're talking about it being a positive number in front of x squared. A is always in front of x squared. If it's in vertex form, a is always in front of the parentheses, right? So if a is positive, we know we're going to have a minimum. So this one would be a minimum. Okay, and the graph would look something like this one that I've drawn already, where it has a lowest point. That's what the minimum is that lowest point. If it was the negative number, the graph flips upside down, and it's got a highest point, and that's a maximum. So really, A is all that you've got. You can decide that before you even knew what that point was. Okay, so if I ask, does it have a maximum or minimum? Just look at A. If A is positive, it's got a minimum. If A is negative, it's got a maximum. That's how you're going to know that. All right. Now, here's where we get into some more intricate pieces that we didn't talk about in Algebra 1. And that's where you get into the focus and the directrix. Okay. The focus is, there's this point that's inside of the parabola. So like here, it's on the axis of symmetry is where it's going to be. And what happens there, I think this is one of the neatest things. Parabolic headlights. Old headlights on old cars were made this way. So the new ones are not made this way. They're really different. But the parabolic shape on the inside of the old headlights, what it did was when that light was emitted from the light bulb, it went out and it hit the side of the reflector, like chrome on the inside. And it would bounce to this focus area, and then it would beam the light out. Okay. Satellite dishes are kind of that idea. They're not parabolic. They're what's called an ellipsoid shape, but it's the same idea. The focus is the same idea. The idea is that if I dropped a point, dropped a rock into this parabola, it would bounce toward that focus point. That's why it's an important spot. If you look at the satellite dishes, I know they're ellipsoid shaped now. They used to be more parabolic back when it first started. But there's that, the satellite guys call it an LMB. It's the place where all the signal comes to, and it faces the dish. When that signal comes from the satellite in outer space, it bounces off the dish and hits that receiver is what it is. The focus point is like that receiver where the signal bounces off the dish. So if I drop something in this parabola, no matter what angle I drop it at, it would shoot it toward the focus. Just like that satellite dish that's mounted on your house, it doesn't move anymore, does it? Y'all don't remember this. When I was a kid, the satellite dishes moved. Like the first ones that came out had a hand crank on them. You had to crank them around until they met up with the right satellite. They don't move now. It's because that shape has gotten better and they can focus it more. And that signal comes in. And no matter what angle that satellite from outer space is shooting at, it bounces in here and it goes to the focus. The satellite people figured that out and said, oh, well, we're going to put that. The focus point is where the signal comes into your house at. It's not necessarily the dish part, but the little electronic gizmos that are there. Guys call them LMBs or what they're called. That's an abbreviation for something, and I don't know what they stands for, but that's what they're called because I've had to pay for them to be replaced a few times. So the focus is based off of the vertex, okay? And the vertex, when you're dealing with a focus, the x value from the vertex doesn't change. So here we got -8. The y value changes on your focus because if you look at it, the x value of the vertex is this point right here at the bottom. It's the same as the axis of symmetry. The focus is going to be on that same line as the axis of symmetry. So it's not moving left or right. It's just moving up or down. So the y values are going to change, and the y values are going to change by a certain formula. That formula is right there on our handout. I'm using h as the x value for the vertex. That's the same thing as -b over 2a. K is the y value from the vertex. That's -56 for this problem. And then we're adding 1 over 4 times a. And depending on what a is, how much that's going to change where that point's at. So we work that out. So I'm going to go to a regular calculator here. I got -56 plus 1 over 4 times 1 is 4. And I'm going to, I know that it's at -55.75 or as a fraction, which is the way I'd prefer it, -223 over 4. So that's at -8, -223 over 4. That's where the focus for this particular graph is at. The x value is never going to change for focus when we're talking about a quadratic function. The y value is the only thing it changes for focus. Okay. Now, the directrix. Directrix. Direct R-I-X. Directrix. What that is it's kind of like the focus but on the outside. And it's a horizontal line that goes that way. It's kind of like it's perpendicular to the axis of symmetry. And it's like, what if it missed it? It would they're equidistant apart is what happens with the directrix and the focus. They're always the same distance from each other. No. Negative 56 is K. If we rewrote that problem in vertex form, we would use, that's where H and K are coming from. They're the vertex that comes from the vertex form, which is why I was using those letters there. Okay. So the directrix, the formula there is to take, it's an equation, it's a horizontal line, so it'll be y equals, and then you take the y value and you subtract 1 over 4a from it. So it's the same number that you added to get the focus. You're going to subtract it to get the directrix. A is 1 in this case, yes. So here we'd have negative 56 minus 1 over 4. Negative 225 over 4. So our equation for the directrix is negative 225 over 4. Y equals negative 225 over 4. All right, so in standard form, we're going to get the axis of symmetry using negative b over 2a. Plug that in to get the y value for the vertex. Depending on what a is that a maximum or minimum? If a is positive, it's a minimum. If a is negative, it's a maximum. And then the focus, you're always going to change the y value. Focus is add, directrix is subtract. Okay, maybe that will help you remember that. Focus, you're going to add. Directrix, you're going to subtract. The focus is a point. The vertex is a point. Everything else is an equation. Okay. When we talk about the vertex, we're talking about an ordered pair. We talk about the focus, we're talking about an ordered pair. If we talk about the axis of symmetry, it's an equation. If we talk about the directrix, it's an equation. Okay. Is that a question?
Could you all three of these equations for one thing?
Mm-hmm. Well, we're finding the vertex, and everything is based off the vertex, so I thought we'll just get them all at the same time. There. All right, so let's look at one that's maybe in vertex form already. So y equals, let's say we had negative 2 parentheses x minus 5 squared plus 3. And remember, vertex form, you don't have to. That's the great thing about vertex form. We're dealing with vertex, right? That's what, axis of symmetry, vertex, and all that. Vertex form is called vertex form because the vertex is really easy to find out of this. We're going to find those same things, axis of symmetry. All right, let's get the vertex. Because we're in vertex form with the problem, the vertex is really obvious. It's going to be HK. Well, if we look at our vertex form, here's an H, here's a K. Here's an H, here's a K. So that vertex would be at 5, positive 3. Because it's a minus sign. It's the opposite of what's happening in the parentheses. It's always going to be the opposite of that. So if it's a minus in here, you use a positive. If it's a plus in here, you use a negative. It's always the opposite.
But it's a plus 3 if we use a positive.
But it's not on the inside of the parentheses.
Oh.
It's only with the ones on the inside of the parentheses that it does that. And so go the opposite there. Once you got the vertex, the axis of symmetry is always going to be the x value from the vertex. So that makes that easy. It's x equals 5. Vertex form is is called vertex form because it makes the things that deal with vertex easy. Okay. Now, is that vertex a maximum or a minimum? Why is it a maximum? Yeah, A is -2, negative number. That means the parabola is going to open down. So it's got a highest point. That makes it a maximum. All based on A being a negative number. Again, that's on your handout. Okay. And then we want to find the focus. Remember, that's going to be an ordered pair. And we're going to take the 3 and we're going to add 1/4 times A. And get that worked out. So that'd be 3 plus -1/8. 3 plus 1/8. Math, enter. Get that back to a fraction form for me. 23/8. Oops. Yeah, 23/8. That's right. So that's my focus. My directrix is y equals, and then I'm going to take whatever the y value from the vertex was and subtract 1/4 times A. So that's the same math I did here. It's just changing that to a minus sign. 3 minus 1 divided by -8. Math, enter. 25/8. So y equals 25/8. And remember, the directrix is an equation.
Where did you get 8?
4 times -2. That's where the 8's coming from for the denominators. 4 times 2 is 8. So
do you go off the previous problem?
I go off of the vertex. Focus is based off of the ordered pair that the vertex is, and I'm going to add to the y value.
I'm talking about like A in the first problem is -2, but now it's -8.
A is not -8. It's this formula is, if you look right there, the formula is 1/4 times A. So A is -4 times -2 is going to be the 8 that we're getting in the denominator. There, it's always going to be 1/4A that we add and subtract for the focus and the directrix. Always. And depending on what A is, what's going to happen out of that. All right. So those are the things I want you to find today. And the maximum and the minimum also tells you which way the parabola opens. If it's a maximum, it opens down. If it's a minimum, it opens up. We know that. We should know that already. And then go from there. Okay. So your problems from the last several days, those 7 through 30. That's what I want you to find me all of these things for that, with the axis of symmetry, the vertex, the focus, and the directrix. Also max or min on the vertex. Find those things. So this goes right along with what we've done. Eventually, once we've done everything for those 24 problems there. So working through those. Okay. I got some spares. So you're working on that. You got the rest of the day to do that for those problems.